Welcome back to the channel. In today's video, we're going to talk about another simple pandas method called Corrwith. If you look at the documentation here, we can see that this is a data frame method. This is the pandas.dataframe Corrwith. And this allows us to perform a pairwise correlation between rows or columns with respect to a specific row or column within that data frame. And so this is a great way to save on compute, or if we have some reference we want to correlate the rest of our data against, we can just do it that way. And so let me show you really quickly in this notebook. We have our pandas.corrwith. I'm importing pandas. In this case, I'm building up a data set. So I have some analytical data here. This is visible and IR data. I have some metadata that we'll use towards the end of this video. And so here I'm just generating that data. This data looks like this. So we have our sample IDs, our components, and the rest of our analytical data. And what I want to do is drop the component column, and you can see we have X head. And what I want to do is determine which column or which row is correlated to one of these samples. So this is just one way to compare, say, N4 against the entire data set. To do that, it is fairly straightforward. We can just say x.corrwith. And let's set it x.low because we want to select a particular row. And let's set that equal to 12 or N12. And then because we are talking about a row index, let's set axis equal to 1. So you can see here, we have our indices. Let's sort the values. And now we have N12, of course, that would be perfectly correlated. And then we have N8, N11, and 13 as the most similar. Now with this, it's hard to know what these are because we're looking at the sample ID values. We actually, if we were to look at component, it would be much easier. And so as an additional bonus piece of information, we can map that component information to this index. So if we select the index, we would just get our index values, and let's chain our map method. And if we wanted to, we could just select all data component, and we would see that glucose, which is in 12, is most similar to mannitol, powdered sugar, boric acid, and lactose. So most of the spectra that's most similar to are other sugars, with the exception of boric acid. I'm guessing that boron has a similar carbon-like profile, but maybe worth exploring in the future. If you were to look at one of the others, such as N33, whatever that one was, we can see that that is phenacidin with lidocaine, and that it is most similar to some of these other mixes, lidocaine with levamisole, lidocaine with some of these other mixtures. And so we can see how looking at correlation with kind of gives us a way to assess the similarity of one spectrum against others, or one sample against all the other sets in our data, and just another tool in your toolkit for performing some comparative analysis using Python and Pandas. In any case, I'll see you in the next video. Peace.